Factor with new techniques. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In our YouTube channel, we have more than 1,000 questions which are based on factoring polynomials. Now, in this video, I'm going to discuss with you four very important techniques which are used for factoring. We'll also discuss how to use them and when to use them. Well, the four techniques which you are familiar with are product and sum method, diamond and box method, Australian method, and here's a new technique which I have come across while teaching my own student. And let me give a lot of thanks to this student, Ivan, who has given me this technique, and I call it advanced method. So it is an advanced method on the Australian method, which will help you factor trinomials where a is not equal to 1. That's an excellent way of doing it. So that is, I think, a very beautiful way of doing it. We don't have many videos on that advanced method. You will learn this technique only in this video. Great. Before we begin, let me also thank all the viewers and subscribers for watching our videos and for contributing regularly. Those who are in Canada, they can always donate using the email address globalmathinstitute@gmail.com. And those who are outside Canada can always contact us on email and then we can work out a method. Your regular support can help us reach millions. Our passion of providing education to all. Now, let's look into these techniques one by one. Here you see, we have this product and sum method, and we also have the box method, diamond box method. Let's take up an example. These six are the examples which we are going to take one by one and also discuss all the four techniques with the help of these examples. So the very first question here is 2x squared plus 7x plus 3. So as you can see, the leading coefficient is actually greater than 1. Okay, so now let's see how do we work with it. Well, if you have a leading coefficient greater than 1, we cannot start with the box. We have to start with product and sum, correct? So let's say, what is the product? So let's say product of two numbers which we are saying m into n in this particular case should be equal to 2 times 3, right? Which is 6. And the sum of these two numbers, m and n, should be equal to the coefficient of x, which is 7. So the combination which can help us give both the results is, of course, 6 times 1, right? 6 and 1. So that clearly gives us that the value of m we can write as 6 and the value of n can be written as 1. So we basically have split 7x into 6 and 1, correct? So what you do really is that you write 2x squared plus 7x plus 3 in the form 2x squared plus 6x plus x, that is 7x, right, plus 3. So what we have done is that we have used this product and sum method to write down the center term 7x as a combination of 6x and x. Now once you do that, now you can also make your box. So in the box, first term is 2x squared, which is the leading term, right? So that is the first term. And then we have the constant 3, which directly goes from the equation, right? Now, these two boxes, which you see here we have to fill in m and n, right? M and n, which is 6 and 1. So that is, you get when you split 7x, right? So 6x and x. So that is your 7x. That is how you get your trinomial. Now, to get the factor, what you really do is take greatest common factor, correct? Now, greatest common factor, I've been saying, start with rows, right? So, first row, 2x square and x is common. The second row, 6x and 3 is common. And therefore, you get your first factor, which is x plus 3, correct? Now, if you look at the column 2x square and 6x, 2x is common factor and x and 3, 1 is common, and therefore what you get here is 2x plus 1. So, using the diamond and the box, we have done the factoring. You see that? But for doing that, we had to use product and sum. You get the idea, right? We had to use product and sum. Now, let's get back to, we're talking about four different methods, right? So let's again take this particular question and see how do we use only product and sum method, right? So once again, we have split this number 7x. We know that product m times n should be equal to 6, right? And m plus n is basically 7, which is 6x, 6 plus 1, right? So the product was 6 and 1. So those were m and n. And therefore, the question before us, which was 2x squared plus 7x plus 3, we could rewrite this as equal to 2x squared plus 6x plus x plus 3. Now here we do group factoring between the two. So 2x squared plus 6x, 2x is common and we are left with x plus 3. And here 1 is common, so we just make group of x plus 3. Now you can see x plus 3 is common. And we get 2x plus 1 as the other factor, and so we get our result x plus 3 times 2x plus 1. So in this case, we have not used the diamond box to do the factoring, but using product and sum, we could factor it. Is that clear to you? Correct? Now let's look into the Australian method, right? You need to understand when to use what, right? So now let's look into the Australian method. So in Australian method, what we do is product and sum is something which we have to always do, right? So we know product here is 6, right? And the sum is 7. And for that, what do we get? We get m as 6 and n as 1, right? That's what we get. Now, in Australian method, what is done is something like this. It may be new for many students here in Canada and US. Now, let's see, what do we factor with? So 2x squared plus 7x plus 3. So what they do actually is they straight away write 2x plus something, right? And since we have 6 and 1, right? So they directly write 6 and 1 here and 2x plus 1, right? But you can clearly see that this 2x and 2x is 4, right? Therefore, we should be dividing this by 2. We should be dividing it by 2 because when you multiply 2x square and 2x square, you get 4x square, but we need only 2x square, right? So you multiply, you divide by 2. Now, in this particular case, it is a very simple case. So you could rewrite this as, so when you divide, you can divide the first factor by 2, both these terms, right? So you can think like this, dividing the other one by 1, right? So what you get here is x plus 3 times 2x plus 1. Makes sense? So see, using Australian method is very efficient in such cases. We directly got the answer by the product and sum combination. Earlier, you notice that there were many steps involved. You get the idea. So it is a much faster way of doing. Is it making sense to you, right? This was a simple example also, right? So it was a much simple And see how beautifully we got our result. Now see how our advanced method works in the same case. Now in advanced method, what we do is we consider this equation as something like this. We've done the product and sum, right? Let me call this as advanced method here itself. In advanced method, we do not write 2x plus 6, right? We just write x plus 6. The two factors were x plus 6 times x plus 1, right? However, you can see there was 2 there, right? So what we do here is that we divide everything by 2. You get the idea. So we divide this by 2. Correct? So when you divide this by 2, let me rewrite this. So what you do here is that you divide this by 2. The numbers. Thinking that 2 has been taken common, think like this. 2 has been taken common, it's 3 by 2, right? So now, if you divide this by 2, what do you get? Look here. You get x plus 6 divided by 2 is 3, and here you get x plus half. Now, x plus half is same as 2x plus 1. You see that? And we get a result. So this is advanced method in which we write the factors as a linear without a fraction. You get the idea. So x plus half is written as 2x plus 1. X plus 6 over 3 was directly as x plus 3. Did you understand? So it's related with Australian method to some extent, but it is more efficient than the Australian method, as you can see directly here, right? Let's take up another example to understand where to use which method, right? Now here we have a degree 4 equation, correct? X to the power of 4, 11x square plus 30. Now in this case, you see that x to the power of 4 and x square, the degrees are double, right? So we could use same techniques, right? Think like this, let x square be equal to p, then x to the power of 4 will be p square. Makes sense, right? So I could write this as p square plus 11p plus 30. Now that becomes a very simple case where the leading coefficient a is just 1. And for this particular method, product and sum is the best way of doing it. Now directly, product is 30 for us, correct? Sum is 11. The two numbers are 6 and 5, right? 6 and 5. And therefore, we can now write down the answer, which is p plus 6 times p plus 5. Is that clear? And then what is p? P is x squared. So we could write this as x squared plus 6 times x squared plus 5, and we get our answer. You see that? Now, when you do product and sum in such cases, you do not have to do diamond box method or Australian method or the advanced method. This is our basic, right? So just product and sum is good enough for such examples. Now, sometimes you may be required to factor it further. Is that clear to you? That's a different case. Purposely, I have not taken that case here in this exercise. But in the playlist, you will get many examples like x to the power of 8 minus 1. You may have to factor it again and again till you reach the lowest form. So, tip is that keep on factoring till you reach the lowest form. So I hope you have understood to some extent when to use which method for factoring trinomials. Perfect? Well, in case you want to learn directly from me, feel free to write an email on globalmathinstitute@gmail.com. We're taking new students these days. Perfect. Now, let's take up the next example, which is to understand how do we apply very effectively these four methods, right? So the example for us is right here. We have 6x squared minus 23x plus 15. As you can see, the leading coefficient is not 1, it is 6. So in this particular case, we need to definitely find product and sum. Now, how do we find the product and sum? Well, the product is clearly 6 times 15, right? Product is 6 times 15, which is 90, and the sum is minus 23. Sometimes it is a challenge to get this combination. How do we get this combination is something which we will also understand here. So let's look into the product of 90. Instead of writing 90, it will be a good idea to use 6 times 15. See how and why. So let's use 6 times 15. And instead of multiplying them, let's factor them. So if you factor 6, you get 2 times 3. And if you factor 15, you get 3 times 5. So basically, to get negative 23, we have to use two numbers which are negative, which when added will give you negative 23, and when multiplied will give you positive 90. Now we know we have to only work with 2, 3, 3, and 5, and that gives you the answer. If I combine 2, 3, 3, 9, and then 5 gives me 23, both negative, correct? And therefore, we get the value of m as negative 18 and the value of n as negative 5. Makes sense. So you see, sometimes it is even important not to multiply, not to write them as a product, but as factors. Since we are really interested in finding the two numbers which add to minus 23 in this case, the coefficient of x, right? Once you get that, we can straight away put these values in the box and answer the question using diamond and box method. So we'll have the 6x squared as our first term and the constant 15, which are placed diagonally. And the other diagonal is for this combination of minus 18x and 5x minus 5x. Correct. We can now group factor. So the first, starting with the row, we have x common, and the second row, we have minus 3 common, right? Okay. So we have our first factor, which is x minus 3. Now let's look into the column. 6x squared minus 18x will give us 6x as a common factor, and between minus 5x and 15, minus 5 is common, and therefore we get 6x minus 15 as our answer. Is that clear? So we have done this using diamond and box method, correct? Now, let us do the same thing using the Australian method, and then we will have the advanced method. Okay, so now look at the Australian method. We are now factoring 6x squared minus 23x plus 15. Now, product and sum is a common thing which we have to do for all, right? Whether you use diamond method with the box or you use it with the Australian or advanced method, right? So we do get minus 18 and minus 5 as m and n. Now to factor using Australian method, we'll write this as 6x minus 18. You get the idea? Times 6x minus 5. However, 6 times 6 is 36. So we have to divide this by 6, correct? Now, dividing by 6, if you look at it, you can see what can we do, right? So the first one, 6x and 18, can take care of this 6, right? So what we get here is x minus 3, right? So let me write this as equal to times 6x minus 5 as our result. So we do get x minus 3 times 6x minus 5. Is that clear to you? See how beautifully using the Australian method we got our result. Is that clear to you? Of course. Now let's look into our advanced method, in which case also the first step is common, the product being 90, sum being minus 23, and m and n values are minus 18 and minus 5. And therefore, 6x squared minus 23x plus 15 can now be written as, so see, now we are not writing 6, right? We're just straight away writing x minus 18 and we divide by 6. You get the idea. Times x minus 5 divide by 6. Now, once you have this concept of factoring, we're basically equating it to 0, right? So here, the first one is very clear, which is x minus 3, but here we will not write as a fraction. We'll write this as 6x minus 5. You get the idea. And we get our result, which is x minus 3 times 6x minus 5. You see how we work? So that is our advanced method. Perfect. And it works very beautifully for all these questions. Correct? So I hope with this you have learned a very important strategy. Which method to apply when, right? That is the kind of idea. So we discussed all the four methods. Product and sum is common. You have to always fill up this, right? Until and unless you get these two values of m and n, you cannot factor. Only if you get the values of m and n, you can factor. Once you get this value, and once the value of a is greater than 1, right? So these methods you will come to know are important if a is not equal to 1, right? Let me write this. In that case, we use these methods. Australian advanced method have some similarities. In Australian method, we divide everything by the leading coefficient a, but in advanced method, we use the fractions very critically to get our answer, right? Diamond and box method is an excellent visual method. After factoring, you group factor the rows and columns, get your result. So I hope with this you are able to now understand and apply this strategy to the other questions. So we did three of them. I'd like you to do the other three as a practice question. We'll take their solution in the next video. I hope you understand and appreciate our strategies. Let me once again thank all our viewers and subscribers for their contributions. Keep contributing as we want to reach the millions. See you and all the best.